Okay, up next we've got Michael Collins. Sorry, the sunlight getting my eyes. Chief Scientist at Red Jack, and he's going to talk to us about sensor network.
Thanks, Foy. All right. Okay, folks. So my name is Mike Collins. I am the chief scientist for a company called Red Jack. Before that, I was at the CERT. I did a bunch of stuff. I like to think that the reason that you're all here is my fault. It's but you know, the CERT's done an enormous amount of work getting this stuff together over the years, and so I just have to sort of stare and be amazed at the fact that I'm talking to 100+ people about anything that I'm doing these days. I've also written a book on flow analysis. You might have heard about it once or twice or 30 times by now. I will say that I think its Amazon sales rank is currently 80,000 and 110 in network security. And I believe that if we get enough copies so that it's number 13 in network security, it'll have beaten out Alan's book, at which point we'll do a death duel for you guys, okay? Anyway, so what I'm talking about today is what I call Vantage Analysis. You know, you know how it is when you're a scientist. If you're given enough time, you're going to build systems, and then you're going to name them and make everybody else follow you. So the point of Vantage Analysis is it used to be easy. You had one single access point, you had one single IDS, and you know, you had all of your attackers coming in some other way anyway, but you thought you knew what you were doing. The problem we've now got is that when you build networks, you end up with multiple points of entry using SIM, SEM, CM technology, which is collecting information from a bunch of different locations. And the problem is that you run into this situation where you're getting hit with both what I call blind spots and repetition. Blind spots are the easier thing to understand. Repetition is more insidious. The problem with blind spots is you don't know what's going on your network. For example, you've got 2 access points onto your network, you're instrumenting one of them. Anything that goes out the other access point, you don't know what's happening. There could be exfiltration, there could be torrenting going on, somebody could be running a small cloud and renting out services, and you have no idea. Repetition is actually more insidious. It's the same traffic being recorded at multiple sensors. Now, historically, we're like, oh, what do we care? That's more data for us. I'm going to say right now that basically, the problem there is disk space is limited. If you're just recording the same phenomenon over and over again, you know, I don't care to see packet 5,000 of a dancing cat video in the first place. I don't need 7 copies of it, and it costs me disk space and time to keep around that particular dancing cat image. So Vantage Analysis is a way to systematically look at the problem of sensor data collection and figure out where we need sensors and where we can get rid of sensors. Now, Vantage Analysis consists of 2 major components. The first is classification. Sensors are classified along 3 axes, which we call vantage, domain, and action, and I'll get into those in a moment. And then there's the actual taking a look at how the various sensors are related to each other in a graph. What I've got here, if you do get the book, obviously buy that book. This is a diagram from the book, which is just a simple network showing most of your common mechanisms for copying data, for instrumentation. You've got taps at various locations, you've got logs at various locations, you've got a spanning port, all of that. And then the figure on the right is the decomposition of this thing into a classic node and links graph. Okay? So why are we doing this? Okay, well, I'll say this right now. Data collection's done. All right, we've done it. We know how to do this. We've got clouds. We've got large-scale storage systems. We've got large data centers all over the place. You can collect as much data as you want. You can instrument yourself into blindness. Okay, if it takes you 4 days to study the hour's worth of data that you've collected, you've got a problem. Okay. The other problem is that network design is increasingly complicated. Part of this, we're all security people. We're all used to that stovepipe where we're doing our security problems. The networking people are on the other side, and their concern is shifting packets as quickly as possible, and our concern is trying to prevent people from doing anything if we can get away with it. And there's a slight conflict of interest there. So you've got those multiple hands on the levers, and you've also got the problem that you've got more mobile devices, and you've got a lot of ephemeral stuff where we used to have hard-coded IP addresses that we knew exactly where it was. It's now DHCP, it's NATed, it's behind, what was it, 7 proxies? And we just can't tell as easily where anything is anymore. And finally, of course, and this is the lament of every network security person ever, all the information we need is scattered in multiple locations. I'll say right now, I'm not really sure it's possible for any instrumentation system to be perfect. What I mean by perfect is I mean that you have complete coverage. That is, every interaction between any 2 IP addresses that you care to mention is monitored. And I don't know that you can have it both complete and non-repetitive. So my expectation is you're always going to have some degree of either blindness or repetition. I haven't proven that yet. I'm not a mathematician, I'm an engineer. But it's an interesting question to ask. And if anyone solves it, all I ask is that you credit me and buy the book. Okay, so as I said, Vantage Analysis consists of 2 major steps. The first is classifying your instrumentation points, and you do that by breaking it into 3 categories: Vantage, Domain, and Action. We'll cover this in a moment. And then the second part is taking all of these things, putting them in a graph, and identifying where points overlap on the graph. I'm going to go through each of those steps now on my sample network so that you can see what's involved. Okay? So first off, there's Vantage itself. Vantage is expressed as pairs of IP address ranges. So source range and destination range with both directions recorded. So for example, if you have a sensor that's got, let's say, 128.200/16 behind it, and then the internet on the other side, the Vantage is 128.200/16 to the internet, or internet to 128.200/16. There are a couple of special ranges that are associated with this. So you'll note, for example, that I have 128.112 TCP/80. That's to indicate that I'm monitoring a particular service there, probably HTTP, although of course it's security, so verify. Single addresses are an issue. And then I use the term internet to refer to everything that isn't on the network itself. So that's simply a bucket for anything that we do not explicitly control. All right? In addition to having Vantage, all of these points have a domain. And a domain refers to the data that can actually be collected. And there's 3 categories of domain: network, host, and service. Your network sensors are basically PCAP and anything derived from that. So TCP dump, flow, anything that you would collect from the wire or the SPAN port. Host refers to state information about an individual host. So memory, disk space, anything that you would get from some kind of host-based intrusion detection or monitoring system. And then service. Service refers to logs associated with a particular service. So FTP, HTTP, SMTP records, things like that. The different domains really refer to the fidelity of the data, and they affect decisions about repetitiveness. So for example, I have a web server running, okay? Obviously, and I have a monitoring point right outside of the web server, and I have the HTTP logs. So we're going to have an overlap in Vantage there, but we have different domains. The HTTP server is going to be within a service domain, or the HTTP server logs are in the service domain. They will see HTTP. They will understand HTTP in a way that the network sensor isn't. The network sensor is going to see repeated packets, it's going to see dropped packets, it's going to see scanning, it's going to report all of that information to me. Somebody sends a crafted thing that looks like an HTTP session without a response, they just send a packet without a SYN, but with a payload marked get/. From the network perspective, that looks like an HTTP session. On the other hand, the higher fidelity, tighter domain service log, the HTTP log, is going to be able to tell me this was a session, this was not a session. Conversely, all the scanning that happens never triggers an HTTP session. I could scan that machine till the end of time. The network-based sensor is going to see that, or the network domain sensor is going to see that. The service domain sensor isn't going to see that because it never triggered an HTTP session. And that's one of the key things we see is you've got these different blind spots with each sensor. And finally, there's action. Action is a description of how the sensor affects the collection process itself. And there's three basic actions. The first action is reporting. Reporting is you simply describe what you saw. NetFlow reports, PCAP reports. The second category of action are events. This means that the sensor makes a decision about whether or not to report data. Okay? And finally, there's control. And control is the sensor makes a decision to do something with the information that triggered that data. The classic example of control impacting Vantage is you have a firewall, and then downstream from the firewall, you have a network sensor. The firewall blocks, so the event that the firewall reports on, the network sensor is never going to report on because it was always stopped by the firewall. Okay? Now, the major item in doing Vantage analysis is looking for overlaps. Overlaps happen when two sensors have a similar vantage. For example, I have a sensor that monitors 128.2.0.0/16, and then another one that monitors 128.2.24.0/24. Okay? You identify these things by going to that table I created earlier and looking for source and destination IP spaces that overlap each other. In your best case scenario, when you've got similar vantage but different domains, you pick the narrowest domain because that's going to give you that's going to give you higher fidelity information about actual impact. Okay? So, for example, we go back to the diagram I showed earlier, and there's the graph decomposition over there. Now, when you take a look at the graph, you'll notice that basically the nodes on the graph are actual hardware, and then the links are basically just the wiring connecting everything. Okay? So the first step is figuring out your instrumentation points. This basically boils down to, do you have a promiscuous device or a tap of some nature, in which case the Vantage is going to be the entire collision domain. If it's a switch, then it's going to be a mirroring port, and the Vantage at that point is everything that it mirrors. If it's a router, it's a monitoring point, at which point the Vantage is the VLANs for that router. And you draw the graph from there. Okay? You then create a table showing the relationships. In this case, I is used as a shorthand for the internet. But you can see what I've got here is that each of the monitoring points is listed by its Vantage, the source and destination, and then the domain proper, each of the individual networks, and then my one particular service-oriented one where I've got the specific service listed. Okay? Now, the next point is to evaluate the Vantage points. I have the feeling this degenerates down to the knapsack problem, so the optimal calculation is likely going to be NP-complete. The way that I've done this so far is I've worked with greedy algorithms. What I do is I go back to the table, like so, and I calculate the total number of addresses observed in the source and destination columns, and then I pick the largest set of addresses each time and move it down from there. Okay? We identify overlapping vantages, and then we say we'll take this instrumentation over this instrumentation if we're concerned about it. Okay? Now, that's basically how the analysis operates. This is a moving target. What I was hoping to do originally was demonstrate a piece of software for this. It'll be coming out in February. The first version of this analysis is in the book. Updates are at my website. There are some notable future moves. The first, as I said, is automating the entire process of Vantage analysis. The other thing is to work on errors in accountability and tracing, so to deal with natting and anything that mutates addresses. There's also some work to be done on the more complex reactions, like when you block an address. So that covers the presentation. Any questions? Yes, John.
So one of our problems when we deal with really complex networks is nobody has their hand on the information necessary to construct these graphs.
Correct.
So the interesting question is, if you are given an arbitrary sample of data identified by the vantage point ID from which it was taken, how good a job can you do?
So that's really a messy question, and part of it, we're always going to have to make assumptions about, for example, continuity of IP address spaces. So if, for example, let's say that I do traces and I find out that I've got address 23, address mumble mumble 23 and address mumble mumble 25, do I assume that I'm missing address mumble mumble 24 there? Because there's an argument for and against that, depending on the type of information you've got. If we assume some minimal degree of continuity, then what we can do is we can collect the traces and we can sort of break the system into the smallest continuous networks and then estimate the dark spaces that we've got from there. And that's sort of the jumping off point for figuring out how much coverage we really have.
Okay, and what happens if I give you multiple sensors that contain 10.mumble.mumble.mumble? Do you know whether you have an overlap or independent uses of the private address spaces?
Well, private addresses ruin everything. You know, what you are dealing with at that point is you're probably going to have to combine it with some kind of active monitoring, because you're right. If somebody gives me two things with 10 mumble mumble mumble, I don't know whether or not I'm seeing the same 10 mumble 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 everywhere.
Okay, thank you.